Okay, I think we can start. Welcome all to our presentation on building data pipelines for a modern data warehouse solution with Spark and .NET. My name is Michael Rees. I'm a program manager on the Azure Big Data team. You can follow me on that Twitter handle. I even gave you my email address if you have any questions. For those that just came in, the QR code here allows you to go to a slideshare.net site to download the presentation. So if you want to have your own copy of the presentation while following along during the presentation, feel free to do so. If you want to tweet about the topic, MSBuild hashtag and .NET for Spark hashtags are two recommended hashtags to be used. So what is this presentation about? This presentation is first giving you an introduction into what is a data lake, what are data warehouses, and how they kind of combine into a modern data warehouse architecture. Once we've done that, we are happy to announce and introduce the .NET Spark offering that we have released at the Databricks Summit, I think about 10 days ago or so, and basically show you how you can use that to build Spark solutions using .NET and can use Spark to scale out your .NET code. How many of you know what Spark is? Okay, about half. How many of you are .NET programmers? I was expecting more. So we will be going into a little bit what Spark is for those people that don't know, and basically show you how that kind of works with .NET. And then we tie it all together with a little bit of a short demo at the end to show you how you can use SQL Data Warehouse then to model and serve the resulting data. So now let's start. How many of you know what a data lake is? And how many of you think that a data lake is going to replace a data warehouse? Okay, that one person and that one person over there. I hope I will be able to change your mind. So a traditional data warehouse is basically kind of giving you the ability to take data out of multiple data sources. You do a ETL transformation of that data into a schema in your data warehouse that is basically there designed to answer the question that you want to have answers for. And then you use your BI and analytics tools to kind of do pretty pictures on top of it. Now, traditional data warehouses had several challenges over time. First, data volumes would increase, and the traditional data warehouse would basically not be able to manage the amount of data that you're getting. Now, that has been addressed. You have several scalable data warehouses, including Azure SQL Data Warehouse, so it can scale to that. And then you got other non-relational data sources that are being added to the mix. And now your data warehouse needs to be able to operate on non-relational data sources as well. Well, again, SQL Data Warehouse, for example, added support through Polybase that gives you the ability to schematize such data through external tables and then integrate it into your data warehouse experience. But one thing, and then you have cloud-borne data and you have on-prem borne data, and so you now need to be able to deal with it in the cloud as well as on-prem. And again, traditional data warehouses have been able to kind of give you an offering. However, what they can't give you an offering or a solution for is that you always have to have a schema inside your data warehouse. You always have to know what is the question that you want to have answers for. So a data warehouse is basically designed for questions you already know that you have. Now, a data lake, on the other hand, is slightly different. So what does a data lake do? Well, it takes all the data that you might have, regardless of whether it's structured or unstructured data, and you basically ingest it into the data lake and store it in its native format, or as close to the native format as you feel is appropriate for your future understanding of the data. Means, for example, you might want to standardize on an encoding and not use Shift.js 5 encoding and Unicode encoding and Windows 1252 encoding, but unify that, for example. Now, what is the benefit of this? Well, now you can go and take a look at that data and analyze it. For example, you can create individual data warehouses. You can cook the data into a data warehouse schema, that you then can use to answer a specific question. But if you then 5 months later come back and say, oh, I need a new question answered over the same data, you're not having the issue that you have with the data warehouse, that now that data warehouse is not really there to answer the question and your operational data has disappeared. Now you can go back to the data lake and say, well, I still have all my original data. I can now answer new questions with it and create a new data warehouse. Even if I don't know what question I actually want to have answered, I can go back and run some machine learning algorithms on the data, hopefully, if I know what it's doing, and find out what are some interesting characteristics of the data before I start creating my data warehouse on it. So basically, a data lake is designed for the questions you don't yet know. And now by combining the two, what you're getting is what we call a modern data warehousing infrastructure, basically the ability to take your data lake, be able to operate on all kinds of data, and then combine it with the standard efficient data warehousing technology to actually get you to that point of answering the questions. There are other kind of paradigms that help you with in the context of like data processing and big data processing, such as advanced analytics and real-time analytics, which will not be topic of this presentation. We have other sessions that are going to go into more detail on that. So let's focus on the first one. Now, if you want to see how to build such a system, unfortunately, there is not just a single off-the-shelf offering right now in Azure that allows you to build this architecture. You have to take a few of our components that we offer inside Azure and put them together to build that architecture. That has benefits around flexibility, and it gives you a little bit of flexibility in terms of whether you need a specific component for your specific scenario or not. But of course, it makes it a little bit more difficult as well. So let's assume we have data, both our log file, unstructured data, etc. And we do have potentially structured data either in, let's say, an Oracle database on-prem or inside even a SQL Azure database, etc. And now we want to basically build such an architecture. So what do? At the beginning, we take our operational data and we basically ingest it into the system. Normally, the kind of component that we recommend to use that for is Azure Data Factory. And then we store the data somewhere. Now, that's basically where the storage part of the data lake comes from. So that's why we offer you Azure Data Lake Storage Gen 2 right now, storage solution. But for example, if some of your data is highly relational in nature and you don't gain anything from putting it into a file system, you could add an additional component to that storage layer, which is just, for example, a SQL Azure DB or something. That way, you don't lose the schematization of the data, for example, and you can still use the virtualization layer of the SQL Data Warehouse layer, for example, then to integrate with it, or the virtualization layer of the of the prep stage that comes next. So once you have the data inside your store, you want to go and maybe train some machine learning models. You might want to analyze the data, figure out what to do with it. You might have to clean the data, prepare it, combine it with other data, etc. That's kind of the preparation and training stage. During that stage, we have several offerings. We have Azure Databricks that gives you an advanced Spark offering, including now support for .NET as a language as well. Alternatives, you also have Azure HDInsight, which again gives you a Spark or a Hive offering to do that. And we also have still Azure Data Lake Analytics available as well in that context. Now, once you have done and prepped your data, you probably want to move it into a data warehouse where you can design your schema for the questions that you want to have answered for. And now inside your data warehouse, you can either connect through Polybase, for example, to the data in the data lake that we will show at the end of the presentation. And then you can use Azure Analytics Services or Power BI to basically visualize it. Now, these steps need orchestration. So for the orchestration step, what you do is you're going to use Azure Data Factory to do that orchestration. Now, a thing that we just announced at this conference as well is the so-called data flow capabilities in Azure Data Factory itself. What that does is it gives you a visual programming for doing simple data preparation steps in your ADF data flow visualization. What it then does is, underneath the covers, it actually translates that into commands that are executed against the Spark cluster that operates on the data that you have inside your data lake. So it actually gives you kind of like a way of visually simplifying the prep and train stage if you have simple transformations. Okay, so any questions so far on this? If not, let's now go and do a little bit of a deep dive on the train and prep stage and take a look at what you can do with Spark and .NET. So what is Apache Spark? Apache Spark is an open source big data platform for data preparation and machine learning and some other use cases in that space that has been designed at a university back in the mid-2000s, I think, and has been released as an open source project in Apache a few years ago. It is more efficient than traditional Hadoop environments because what it does is it added a more general computation graph beyond MapReduce, and it added some in-memory computing primitives to basically give you higher performance than just operating on disk data, like what MapReduce also gave you. And it has become quite popular over the last 5 years. One of the value propositions that it also has is besides just giving you like the map, kind of a more general MapReduce paradigm, it also gives you the ability to develop in the native language of your choice. So it has APIs for programming in Java, in Scala, in Python, in R, in Julia, et cetera, and it allows you to take your user code, like special processing that you might want to apply to your data, and scale it out across many different nodes and basically apply your user code at scale against your data as well. And it is available in Azure in many different ways. Azure Databricks I mentioned, Azure HDInsight. You can build up your own IaaS or Kubernetes cluster and deploy Spark on it. And there are some other products that we are releasing, such as, for example, the Dataflow products that might use Spark underneath. Now, if you are a .NET developer, we have done a recently conducted survey where we asked over 1,000 .NET developers about their kind of big data needs and interests. And more than 70% of those .NET developers expressed some form of interest in Spark. So that means there is a big kind of interest in there. Now, why is that interest? People want to tap into that open source ecosystem. Like we did build ADLA with a .NET experience for big data processing, but it is not an open source experience. You can't just go and buy a book. You can't just hire somebody who already has been doing that at your competitor, et cetera. So you basically want to be able to tap in there for support, code libraries, and even the ability to hire people. Now, if you are a .NET developer or a Spark developer, you can go to Python, you can go to Scala, Java. But if you want to use .NET, right now you have a roadblock. You can't go there because there is no .NET support in such OSS stacks. If you go to Apache Spark, there is no .NET support there right now. So what do we do? A problem for many of the customers is if they want to actually go and use Spark now is that they have to go and actually translate their business logic. Like even in Microsoft internal, we have some people that want to use Spark, but most of their business logic is in .NET. So they would have to retrain the people, convert all the code, et cetera. And that's expensive and difficult to do. So what we are now doing is, by adding Spark support to .NET, is to basically make people happy. So now the path is free to be able to use Spark and .NET together. This is our goal, though. I have to stress here, our goal is not to evangelize .NET to the Spark community. If somebody wants to use Scala or Python because they're familiar with that, more than happy to support them as well. But if you want to use .NET because you are steeped in .NET, now you have a way of using Spark as well. Now, another question that we have to answer often is well, how committed is Microsoft to that? And let me just take you through here. Right now, we are obviously building on top of the Spark, Apache Spark component. Our goal is to contribute the work to Apache Spark so that sometimes next year, hopefully, it will become part of the Apache Spark branch. Until then, we are developing it in the .NET Foundation context, so it's already open source in that sense. We have a deep collaboration with our friends from the .NET team. A few of them are sitting in the back there. Maybe they want to wave quickly. Ankit, team, Pranav, yeah, they're all sitting back there. We have been working the last half a year very closely with them to make this experience not only a good Spark experience, but also a really good .NET experience, and we are still continuing to work on that, as you will see on the roadmap slides. Then from the Azure data side, which is my side, we have been doing a lot of benchmarking and bringing it into our big data products. Currently, it's already out of box in Azure HDInsight, and it will become available hopefully at some point this year in Azure Databricks. We're still talking to the Databricks guys about that. And we already published like installation descriptions, etc. And then finally, we obviously also are working hard on making it accessible to you with documentation and code samples, etc. And we are developing in the open. As I mentioned, it's currently on the .NET Foundation as a project. You can find it on the GitHub. There is another QR code at the end of the presentation if you want to go and like us on the GitHub side. That would be very much appreciated. There is a little bit of a competition among some teams, as you will see with some of the demos, who gets the most likes during build. So I'm counting on you guys to increase our count there. And we also have already filed project proposals to the Apache Spark community. One is to improve the general language interop layer so that it's not only benefiting us, but other languages as well, like Python, like Julia, etc. And then a specific one for the .NET binding. And that is currently being discussed, and the progress that we are making with the project under the .NET Foundation basically will then feed into that as well. And finally, as part of the work that we have been doing to make this a great experience, we have done a lot of contributions regarding like Arrow.NET support, pickling library in the .NET space, improving the performance there, etc. A lot of work has been done there specifically by the .NET team and also one or two of the engineers in our team to make that happen. So as you can see, we are really like engaging here with the open source community at multiple different levels. Now, what do we actually support with respect to Spark? Spark, as I mentioned, is a scale-out platform. It has an abstraction of basically a data object in your programming language called the DataFrame. DataFrame, you can imagine, is like a row set. Or now, it is not an actual data object. It's actually a remotable data object. So if you are familiar with LINQ, it's a little bit like iQueryable in a sense. But it has a very like relational data structure to it. And what we give you is the ability to now have a data frame object in your .NET code, in C#, F#, and you can build up your Spark queries the same way that you would do in Scala. That's one thing. The second thing that we give you is the ability to take .NET user-defined functions, register them with your Spark environment, and then have them executed at scale on the data on your Spark cluster. So you don't have to rewrite your, I don't know, sentiment analysis that you want to apply to tweets on your remote Spark cluster. You can just use your .NET code that you already have for doing so. And this currently works with Spark version 2.3 and 2.4, and includes also support for Spark SQL as well, including all the built-in Spark SQL functions as well. The whole .NET support is built on top of .NET Standard 2.0, which means that it can run on either .NET Framework 4.6 and higher, or on .NET Core version 2.1 and higher. And we're focusing right now on C# and F# support. If you want to use VB.NET, I've been told by my .NET friends that you can do so. It might be a cool demo at some point, but stick with the other languages from my point of view. Now, an important part here is also that when we do performance improvements, though, we are actually focusing on .NET Core. Specifically, also, if you have heard the announcements earlier this week about that, basically .NET Core is kind of like going to be the thing that the .NET team is going to focus on, where they bring in some of the .NET framework stuff and basically make it unified. That is just part of that push as well. And then in terms of scenarios, obviously we are going to support the batch submission scenario, but we also added support for the structured streaming capabilities that Spark offers, so you can use that in .NET as well. And we are supporting all the standard Spark supported data sources. So if you have a connector, then that will work with Spark.NET as well. You don't have to rewrite it into .NET if you already have a connector, for example. Furthermore, we do have included and worked to make sure that we can include ML.NET libraries in your Spark, in your .NET Spark code. So you can, for example, define a model and then deploy the model and do ranking at scale on your data using ML.NET as an example. And last but not least, we are continuing to spend a lot of our resources on making sure that the performance and speed and scalability is provided. Our goal is to be mostly faster if we need interop than, for example, PySpark, and trying to close the gap to the native Scala experience as well. And if you want to see examples, on our GitHub site, we have already ported a lot of the kind of standard Spark examples that you see out in the world so that you can see how it's done in .NET. I will see you one example a little bit later to kind of show you how easy it is to do so. Now, I gave you a lot of abstract talk. Now, let's take a look at some more concrete examples. So here is the first line of almost every Apache Spark program, which is you are creating a session against your Spark cluster. Now, this is using .NET for Apache Spark. If you look at it closely, or not so closely, it looks almost like Scala. So you see here, Spark session is an object you build, and then basically connect. You have to provide some information, obviously, like which cluster to connect to, etc. And then what you normally do is you read some data from that cluster, from your file system, and create a data frame. And again, this is very similar to what you would do in a PySpark or Scala. And then in this case, I'm creating a user-defined function. Now, the interesting part about this is the UDF constructor there that you see is basically taking that lambda expression, which is in this case just the concatenation, and it will be creating a function that gets registered in the context of your Spark session. So it's basically like a very easy way for taking some lambda expressions or some C# function or so and registering it as a user-defined function, which then means you can use it either inside your data frame kind of query expressions or inside a Spark SQL command that you apply on the data frame. So if you look at this a little bit more closely, you see dataframe.filter. Filter is basically a where clause. So it basically takes your data frame and reduces it to all the data frame rows that have an age greater than 21. And then I do a select, meaning a projection, where I take the age and the name of the data frame and concatenate it together, and I do a show. So you see there the concat function that I specified as user-defined function is now being used. Now, to understand a little bit better what this actually does is we have to understand what type of operations we have. So if you look at the select and the filter, these are so-called transforms. Now, transforms are delayed expressions. They are not executed when you write them. So don't worry if you have a data frame with 20 gigabytes of data, it's not all loading it into your main memory. It just tells me now that the query that I'm going to send over to my Spark session will include a filter on this object that lives on my cluster side. And then the same with the projection. When it gets executed, when it gets sent over to the actual cluster, that's done at the action level. So if you say .show or save as or something like that, then it will actually execute that execution tree. It will ship it over to the cluster, and then it will be remotely executed, and it will wait until, like in the case of a show, it will wait until the result starts piping back, for example. Now, if you do a show, you probably want to make sure that you're not like transporting too much data back, so you normally put a limit on it or something like that as well. Now let's take a look a little bit closer at the language. So here is a TPC-H query. TPC-H is a standard industry benchmark. What this does is, let me zoom in a bit so you can see it a little bit better. It basically does a multi-way join here over regions and nations and suppliers and part suppliers, etc. And so what this is basically a join, four-way, five-way join with some group by and aggregation, etc. So this is Scala code. Now let's take a look how this looks like in .NET. Let me zoom in here a little bit. It looks fairly similar. In fact, we designed our libraries to be dangerously copy-paste friendly. So if you go onto Stack Overflow and you want to know how do I do X in Spark, you will probably find a Scala solution posted already. So you can take your Scala solution and basically copy-paste it into C#. You will have to adjust some of the C# versus Scala idiosyncrasies. Like, I'm a SQL guy. I grew up with a single equal meaning equality. Then C# introduced double equals, and it completely confused my brain. And now Scala does triple equals, so it's confusing everybody. But anyway, going back to this, you need to kind of like do some of that adjustment, obviously. Var, val is another one. And then one thing that we currently don't have is we don't have the syntactic column reference, so we have a functional column reference with call. And then, of course, we are following the .NET capitalization rules, which means we have uppercase, camel case for our method names. But other than that, it's basically the same. And the interesting part is, if there is no user-defined function being called by either of those queries, you will get the exact same query plan being shipped over to your Spark cluster, and the performance will be exactly the same. There's no difference. So now let me introduce Rahul, who is the engineering manager of the team that has been building that on our side. He will go and give you some demos, actually showing you it running. Rahul, if you want to take over for now.
Hey, folks. I'm assuming all of you are familiar with TPC-H. I'm going to call out for an exam here. So how many of you are familiar with TPC-H here? No one? Everyone's going to fail. I'm just kidding. I'm just kidding. Like, I won't be using TPC-H at all, I promise, for the rest of this talk. So what I'm going to show you is a very, very simple example of something that you might be familiar with. Everyone familiar with GitHub? Cool, awesome. I see a unanimous nod of all the heads. So there are a couple of tables. I'll show you where to get this data set as well. There are some projects, basically there are three tables called projects, watchers, and commits. As you can guess already from the name, this is just a list of all the projects on top of GitHub, all the commits that went into this particular table, these projects, and there are a bunch of people who are watching. So anytime you click on a star, that's basically just recorded in that particular table. What I'll show you is a simple Visual Studio solution where you can do some simple things like, hey, I want to create a Spark session. I want to be able to do a data frame over these three tables. I want to execute some super simple queries. And I'll show you how to execute that on your local box, and we'll look at some of the results over here. So, sounds good? So before I get started there, right, let me show you something super nice. This is how you go to the project. It's .NET/Spark. This is the website where you go to kind of get started. Let's just go there. I promise it's not me, it's the internet in this room. Yep.
So maybe let's just switch back to my machine quickly. So let me just show that here quickly. HTTP //.net/spark. So this is how it looks like. You might want to just drive it off here.
Yeah, so this is basically the website. You just click on Get Started, and pretty much you will be directed to the GitHub website, where we have instructions for getting started both on Windows and Linux. Yes, we support Linux as well. So the project is completely open sourced. Everything is sitting here. So feel free to kind of get started from that particular page. And let me switch back and I'll show you some stuff.
Okay, I fixed your laptop.
Thank you, Michael.
Tech support during presentation.
Now, let me talk a little bit about the GH project. So I was telling you about this GitHub Dataset. This is a wonderful website. Microsoft is one of the sponsors for this website. What this actually allows you to do is there is a downloads page where what they allow is they give you the ability of doing a download of a monthly data set essentially. So the first of every month, they allow you to just download the whole of metadata of GitHub. So sounds cool, right? I mean, they don't have all the code sitting there, but they have all the metadata that is just sitting here. I can just download this. This is 100 gig compressed data essentially. That's 100 gig. When you uncompress that, it goes to roughly about 350 gigs. What I've done before the session started is essentially upload all of that data set into Azure storage. So this is where I have just plain vanilla CSV files. So you don't need to know any of the columnar formats, all the mumbo jumbo over there. It's basically just CSV files, just extracted out of that archive file and just uploaded into the Azure Gen 2 storage system. And you'll see here that it's basically, one of the first files is about 120 gigs, essentially. The second one, 107. So the whole size of this directory is roughly about 350 gigs. So now let me tell you a little bit about this thing. So these are all the tables that are sitting inside GitHub. So you'll basically see things like the projects table that I was talking about, projects.csv, is actually this particular schema that is right there. So there's no confusion. They provide both the name of the column as well as the type of that particular column. Now you might be wondering, okay, how do I actually load this into my Visual Studio solution, right? I've already followed some of the instructions on GitHub, so I encourage you to kind of see how you can actually get started by just right-click, manage NuGet. You can pretty much go into NuGet right here. So you just right-click, do a manage NuGet, just search for Microsoft.Spark. And you get this, you just install this package and you're ready to go essentially. So that's all I've done here. As Michael was showing you, this is how we create a Spark session. You do a spark.get or create. What this actually does is it goes, talks to the cluster, tells the cluster, hey, I need some compute resources, get me some of the compute resources, and it gives you a handle to that. So in this particular example, I'm using Spark as the handle over here. And just for the sake of this demo, I'll just use a local storage path. So what I've done is I have a sample of the data set just stored here inside scenarios dataset, and that's what I'm going to be using for the sake of this demo. What I've done here is, look at this. If you notice this particular schema that I've actually defined here, it's fairly identical to whatever I've shown you here, pretty much, in the projects thing. I've just copy-pasted that schema, adjusted the types a little bit, like ints and strings, and beyond that, I haven't done any black magic over here. So if you notice, what I've done is I've just said, like, Spark, go ahead and read this particular CSV file. And I've just said this is my schema right here. And Spark will go do its magic. And you'll notice one other thing that I've done here. What I've done at the time of loading this particular CSV file, I've also created a filter right here that will narrow down the data set into just C# projects. That's cool, right? Even before you actually load the whole data set into memory, Spark goes ahead and applies these filters even before it actually starts loading that whole data into memory itself. And similar to that, what I've also done is I've also gotten a handle to the watchers and also the commit CSV files. So pretty straightforward. There's nothing complicated over here. What you can do is what Michael was showing in terms of the DataFrame API or the functional way. This is what is pretty common in the Spark community. What you will see here is I'm actually doing a very simple thing, which is how do I find the top C# projects and order them by stars? That's basically it. So it's a quite simple one. What I've done here is just using the functional API. I'm just saying, hey, take my project's data frame, join it against watchers. If you're familiar with SQL, you'll be super familiar with this. You'll have to kind of wrap around your head with the functional syntax, but I have something cool coming up too. Then you do an aggregation. Just do a count star on top of this, and you order it in the descending order of the number of stars. And all of those are transformation steps. Now, what I'm showing you in line 62 is .show, which is the action that Michael was talking about. Once you do this, Spark gets all the cluster resources ready. It goes ahead and goes wild in terms of executing and getting you the results back. So that's what is happening behind the scenes. Now, you could also do one other thing. If you've looked at this and you're wondering, okay, now do I have to learn all the functional way of actually doing all of this stuff? We got lucky. There is a way you can actually register these projects and watchers handles as temporary views inside Spark. This is equivalent of saying, hey, I'll take this handle, I'll call it a table with some table name essentially. And then look what I've done here. Lines 67 to 73, I've expressed the same functional query in Spark SQL. Basically, it's that simple. So if you look at this query, they'll be pretty identical here. All I'm doing here is projects.join, and here I'm just doing an inner join. So feel free to kind of pick whatever you want. There's absolutely no performance difference. Both of them compile down to the same logical plan underneath, and Spark does its magic internally. So there is absolutely no performance loss or whatnot here. And to make the presentation a little bit more interesting, we'll also do one more thing, which is how many of you have worked in the open source communities? Cool. If you've wondered at any given point in time, hey, do people in the open source land work a lot over weekdays or weekends? We'll try to answer that particular question. Cool. So having said that, this is the code sitting right here. Let me show you how to actually run this. So all I've done is just right-click, build it. Once I build it, I come into my command line, and this is the command. All of this is documented on GitHub. We're working actively on adding some of the tooling pieces. So until then, this is the command line interface over here. So what I've done here is you don't need to worry about this piece. All these are talking about is it's executing the whole thing locally on top of your machine. That's basically what's happening. And you're telling Spark that, okay, use the .NET Core engine, and here's my DLL that I'm actually passing. So once you do the .NET Core compile, this is what you end up getting. I just run.
So this is now basically executing it against the local Spark cluster running on his machine. We'll see how to submit it against the cloud cluster in a bit.
And believe it or not, I'm processing a lot of data in this query. Guess how much? I'm actually processing less than a megabyte, and this is how long it takes on my local box. But just bear with me. This is not what Spark is. But what you're just seeing here is some kind of a local way of, hey, I've written some query, I have some sample data sets, and it goes ahead and prints out those results over here. And these results are totally wrong. The reason is because it's a sample, so it's all wrong. Just bear with me for the time being. And one of the other cool things that you could start doing is, If let's say you want to do some kind of debugging, how would you do that, right? If let's say you kind of gave the wrong pointer to your data set, how would you end up doing that? All you do is just take this out and say, pass in the debug flag, do a run, let it do its magic, let it start. Basically, it now started the whole backend in a debug mode. What you can now do is go back to your project, set a breakpoint, right-click, debug, and start new instance, and watch what happens.
So just like that it sinks in, what he was just doing was, on his local machine, while he's developing the Spark solution on some sample data, he figured he wants to debug the code. So he starts the Spark job on his local machine and uses Visual Studio's debugger now to basically go and debug that. That's actually something that I don't think you can do with any other language except for .NET support and Spark and Visual Studio.
Isn't that cool? Like you did not have to know anything about Java or Scala, nothing. It's basically just getting started with Visual Studio. You don't need to worry about anything over here. And go ahead and look at, like, if you've actually said something incorrectly over here, fix it, rerun your application, and boom, you're ready to go over here. How many people think it's cool?
Thank you.
Now, of course, this is a megabyte data set, right? Now, there might be a question lingering in your mind, like, why the heck would I use this? Like, what's the use case? Now, here's the thing. Like, at the beginning of my talk, I was talking about the 350 gigabyte data set. Now, imagine running this query on top of your 350 gigabyte data set on your machine. Scott Hanselman tried doing that in his previous presentation. It never finished running, essentially. So we have some evidence over there. So what I've done here is, there are instructions on GitHub on how to actually package your application. What I've done right before the session is, there is a cluster that I managed to create on top of Azure Databricks. There are completely easy to understand instructions in terms of how to build your application, package it, upload it into Databricks itself. So what I'll show you is, there is a cluster that I've managed to create, and this is a job. So how many of you are familiar with like Azure Databricks? Okay, so let me do a very quick cover of what exactly this thing is. There's a concept of clusters. Cluster is basically saying, okay, I want to ask Azure for a certain number of cores, certain number of nodes in my compute. How do I actually do that? So if you manage to go into like cluster, create cluster, you can specify a bunch of things that you can do. You can say that, hey, I want to enable auto scaling. I want to terminate the cluster after like 120 minutes of it not being used. How many workers do you want? Like how much do you want to actually scale it to? So fairly simple stuff. You should be able to get started on this after reading some of the Azure Databricks documentation. And then what do you do after you create a cluster? You create a job. A job is basically saying, hey, here's my application code. I want you to actually run this code on top of a cluster. That's all you need to know in order to understand this demo. So what I've done is, I've created this particular job with a lovely heart symbol here, and basically attached it to a particular cluster called a batch cluster. Why am I calling it a batch cluster? Because I'm just running this job on top of that cluster that's already running, because I want to show you something cool right here. Let me just click on run now, and I'll come back to this. But if you go into this batch cluster, you'll actually see something really awesome. Can you count the total number of cores we are actually using for this job? I'm sure we all had lunch right now, so give me a number fast. It's 240 cores. That's what we are actually using.
8 times 30, yeah.
It's the same application that you've been authoring on your local desktop. Now you basically have a cluster that is 240 cores created, and you just ran a job over there. And when will the job finish? I have no idea. And there you go. It's already done.
So you're basically telling me that you took the same program that you just run locally and packaged it up to send it to the cluster. Same DLL.
No changes.
Now it runs on.
Exactly. No changes whatsoever. And look at what happened, right? This is the execution that just finished right now in 42 seconds. Across a table, it must have scanned, 150 gigabytes of data or whatnot. Like the whole example I'll be publishing on GitHub. Feel free to go replicate it on your own. No black magic whatsoever. This just runs out of the box right here. So how do you look at the output? Well, there is one boring way here. The boring way is actually just click on the logs and you have it right here. You click on this guy, I'll give you some stuff, but we don't want boring ways, right? I mean, this is just text. You don't want some of the boring ways. So how else can you look at it? We are actually working on adding some rock-solid notebook experiences for C# inside Jupyter notebooks. So anyone familiar with notebooks? Okay, so notebooks are all the hype now. So if you have a lot of data and you want to quickly iterate on top of that data, people go for notebooks. So you might think, wow, what the heck, this is crazy, C# and notebooks, like how will I actually get this to run? The trick is in getting a REPL to actually work properly. So this is what we're working very closely with the .NET team on, and this is a working prototype, and what we have is you can execute C# instantaneously right there using the semantics that you might be familiar with, Control Enter, and pretty much look at the results right here. And you know, I have some cool thing here, but I will not break the suspense from answering that one question that I raised at the beginning of my talk, which is, do open source developers work more during the weekends or weekdays? And I will let Michael actually take over and answer for that.
Well, actually, I will use Power BI and SQL Data Warehouse to answer that really pressing question. Thank you, Rahul. So thank you. Give him a hand of applause. Now let's switch back to the presentation here. So what we have seen was basically the ability to take your .NET Spark code, develop it locally, debug it locally, and then deploy it into the cluster and run it at large scale over your large amounts of data. So now we have done the data preparation step that we talked about. Now, what is exactly happening when you write .NET Spark code? We alluded to it, so I will go over it quickly. So you basically write your Spark SQL or DataFrame kind of queries. They will get translated by the .NET for Apache Spark component into an operation tree that then gets sent to the Spark cluster. And depending on whether you use a user-defined function or not, it will take a slightly different approach. So if you did not specify a user-defined function in your Spark query, then it will just be executed using Apache Spark. It will have the same performance, same experience as if you would write it in Scala or Python. If you have a user-defined function, there will be some interop happening between Spark and Scala and .NET. And you will basically run with a .NET Core installation in our case, plus Apache Spark. Now, obviously, when you have interrupt, the question is what is the performance characteristics? So what we have done here is that we did some performance tests using the TPCH performance benchmark numbers to kind of look at how they compare if you take the .NET using .NET Core 3.0, Python 5.2, and Scala 2.11.8, and do some performance comparison. Now, the first thing that you see is up there are the response times. They're for most of the results, they're fairly close together. And that has to do with whether there is actually any interop or not. So the next graph below kind of shows you which of the queries we added user-defined functions to kind of mimic and force that interop. And you see, for example, query 1 does numeric data, 3 billion rows. Query 8 does 2 billion rows of numeric and string data. Query 13 does 400 million rows of just regex expressions, or probably string. And if you look then up at the queries result time, you will notice that for all queries except for 1 and 8, you basically have that the UDF either does not get invoked or it does not have a high performance impact. And if you look at those queries, you will notice that the query response time is basically, let me zoom in here a bit, is basically within the margin of errors, which is that black bar at the top there, of each of the runs, which means there is basically no difference. The big difference happens on query 1 and 8, where we are transferring a lot of data. And the interesting part there is as a takeaway, just with our initial performance work, that's not even including all the performance work that we are currently working on, we are up to 2 times faster already than using PySpark, using Python. Now, we are working on some other things, like instead of using pick links, using arrow, etc. And we expect those numbers to get better in absolute terms, but keep the shape of the comparison about the same. So basically, given that we are thinking that we are going to get much better performance than, for example, using Python in this case. Now, we already mentioned a little bit that we are working kind of on making this a cross-platform experience. So obviously, you can run this on Windows, Ubuntu, macOS, everywhere where .NET Core basically works. And we also can use it cross-cloud. So we have shown you on Azure Databricks. We also have instructions on the GitHub side. If you really need to do it on AWS, you can do it on AWS as well, both in Databricks or EMR. And as I mentioned at the beginning, we already have it out of the box, so you don't even have to deploy any Spark.NET runtimes in the HDInsight cluster. So if you create an HDInsight cluster with HTTP 3.6 and Spark 2.3.x, you will get .NET support automatically in the box. Let's go to the next one. We also are working on our tooling story. So right now, we do have Visual Studio, a VS Code extension that gives you the ability to author, run, and debug your Spark jobs. Right now, this is working and integrated with Azure for HDInsight clusters. I think it will be released later this month as a kind of a preview version. And we are planning on also integrating it with Azure Databricks as well. So besides, and this is now for cluster-side development. So what we have shown you earlier is like using Visual Studio today just for doing local, but this will actually have then submission against clusters and everything integrated as well. So what is next in terms of roadmap? Obviously, we are looking at adding more programming experiences. We currently do not support the ability to have user-defined aggregation functions or, for example, multi-language support where you have a, let's say, a notebook where you have in one cell you call a Python library and in the other cell you call a .NET library. That's currently not supported. But if you have such use cases, please let us know. We are looking at providing you a more idiomatic experience. Right now, as we talked about, the DataFrame experience is very centric towards like people that know Spark or can copy-paste Spark code over into .NET. But we have a lot of fans, especially in the F# community, but also in the C# community that want to have more idiomatic experiences like a type provider, for example, that gives you much better IntelliSense. Things like that. These are things that we are looking at in conjunction with the .NET team. So if you have any preferences and requirements there, please let us know. We are looking at data connectors that can be written in .NET. Right now, they are mainly written in Scala. And so we are kind of looking at more of that. We talked a little bit about tooling experiences. You saw the demo of the notebook experience. So we are kind of working on making that a major focus on over the next half a year. And then the out-of-the-box experiences that we mentioned earlier as well. If you want to let us know what is important, please go to the GitHub site and basically leave comments and feature requests there. We are more than happy to engage with you on that side. Now, having said all that, now let's go a little bit into the serving mode and also answer the question that we still haven't gotten, whether people that are doing open source are more weekend warriors or are actually fully gained employed people doing development. So for that, I'm kind of using SQL Data Warehouse to do so. Now, if I have data, obviously, inside my data lake that I just cooked and prepped using Spark, I will have to currently get that into my SQL Data Warehouse in some form. Now, there are a couple of options here. The first option is that I go and create an Azure Data Factory pipeline that picks up the files and copies it over. How many of you like that? Nobody. Well, sometimes it's what you do, but there's a second option, which is that you basically can use the Polybase experience in SQL DW to build an external table over that data that you have just processed, and then load it into your SQL DW either on demand, meaning you just run a query against that table, or if it's a lot of data, right now you should probably copy it into a correctly distributed and scaled out SQL DW table to get benefits of the SQL DW scaled out query processor. Because the direct query against external tables currently always reads all the data into your SQL DW temporary space. So you're not getting like predicate pushdowns or partition elimination done. So if you have a lot of data, like 300 gigabytes of data, you should probably copy the data through that table into a table that has the right distribution, for example, so that you can make use of all these query optimizations. And then you use SQL Data Warehouse and Power BI as appropriate, like you can do joins with other data, you can create a report, etc. So let's take a look at that a bit as well. I'm jumping over that quickly. This is just how to create an external table. So you basically use an external data source. You create one per store account. We support WASB, ADLS Gen 1 and ADLS Gen 2 for that. In this example, you see how to do it on an ADLS Gen 2 account. You obviously have to provide a credential that you create that I'm not putting on the slide for security purposes. Then you create an external file format, which is basically saying how should you parse the files that you encounter inside that store account and make a schema out of it. In this case, for example, I show you how to do it with a gzip encoded Parquet file. You can also do like ORC, RC, CSV, TSV, etc. There are a couple of ways of doing that. And then when you create the external table, you give the relational schema the location where the actual folder is, where it contains the files that you want to have parsed. And obviously, you provide the file format and data source. And then you use it. In this case, I do a copy into another table, etc. So let's show you the example directly on here. So what I have here is a SQL DW instance that I have created inside my Azure subscription. I did that 3 days ago in preparation of the demo. I didn't shut it down, so Microsoft will get a big bill from me. And the first thing I did was I basically created that external data source. Let me zoom in again. On a specific HFS ADLS Gen 2 location with my credentials here. And then I created external file format. In this case, the files that we created with the Spark job was CSV files with a header line that told me what the semantics of each of the columns is. So in this case, therefore, I go and say I take first row starts at 2. So I basically skip the first line. And it's a comma-separated value. Okay, it tells me that I'm over my allocated time. I'm almost done. Now let's go and show you the actual query. So here what I do is I create an external table, patterns import, where I get the 4 column names like the project name, commit date, commits, and stars, etc. And I get it from that location where presumably his job has written the files into, using the data file and the format file that I had. And I just do a select star, and maybe just to show you that I'm actually doing some real work here, add some order by here. So I say order by project name, comma, commit day. And let's run this quickly. So what this is now doing is this is SQL DW running against the data that we produced in our Spark cluster, stored in ADLS Gen 2. So you see here a nice tabular response, but that's really not easy to answer the question. So what I did was I went to Power BI and basically got the data from that table, connected to my SQL DW instance, and just said I want that table to be visualized. I played around over here on the visualization part a little bit to kind of get the right visualization done. That's actually the hardest part. at least for people like me. And so what you see now is the visualization on this side. You see the x-axis, or the horizontal axis, is basically giving me the projects that we have. And the vertical axis gives me the percentage of how much each project worked on each day. The weekends are the top row and the bottom row, so the kind of orangey color and the green color. That's because Americans seem to be taking Sunday as the first day of the week, and so it ordered it in this way. So you can see now, to answer the question that we asked at the beginning, are people more productive as open source contributors on the weekend or not? You will see that it depends on the project. Specifically, if you look at the projects such as, and let me zoom in quickly again, PowerShell or CoreFX or Roslyn, these are Microsoft projects. So most of the work is done during the week. CodeHub, however, seems to be more of a kind of non-sponsored open source project where people are spending a lot of time on their weekends to do commits and work on it. So you can tell now that with our little analysis here, that a lot of people that are working on open source projects that are not corporate backed, they are doing indeed a lot of work on the weekends. So having shown you that, let's quickly go and summarize the presentation. We would like you to kind of engage with us and start using the .NET experience on Spark. If you use this QR code, it will take you directly to the GitHub site. So you can log in and give us a star. That would be highly appreciated. You also have the links there. We have a link to the SPIP Jira. Having upvotes there also helps us with convincing the Apache community to accept us into the Apache fold. We mentioned that it's available out of box on Azure HDInsight Spark, and we do have very good descriptions on how to install it in all the other ones until they become out of box available as well. And we hope that at the end of this presentation and after you engage with us, that you also will start loving Spark and .NET together. Thank you very much, and have a great rest of the day.